Hey guys, today we're going to be looking at gas laws stoichiometry, which is not as intimidating as it sounds. We're just going to be learning one new conversion to use in conjunction with all the conversions you learned from last unit. Be advised, your test over this is going to be on Monday, so be ready for that. All right, I'm actually going to skip over this top section. The top section here talks about all the conversions that we already knew from last unit, just to have them for reference there, if you want to look at them. We're going to start down here today with our new conversion, which converts from moles to liters, but it can only occur at STP, which is standard temperature and pressure. So the question has to say at STP. Otherwise, you're going to have to use the ideal gas law. So the conversion is that 1 mole, sorry, let me get the right pen color here. 1 mole equals 22.4 liters at STP. It's always the same number. You don't have to calculate it. So let's go down here and see how to use this in our conversions. First conversion here is how many liters are in 5.2 moles of O2 at STP. And it says at STP, so we can use the conversion. First step is drawing the chart. After you draw the chart, you write down your given, which is 5.2 moles of O2. And the conversion we just learned is that 1 mole of O2 is 22.4 liters, and we are going into liters here. Now we're going to need to plug this conversion into the chart. Right now we've got moles on top, so the moles part of the conversion has to go on the bottom. 1 mole of O2 equals 22.4 liters of O2. Moles of O2 cancels out, and you got liters left over. Last thing to do is find a number. You multiply 5.2 times 22.4 divided by 1 to get 116.48, and that is liters of O2. Now we can also use this in conjunction with the other conversions we learned last unit. Let's see how that works in these next two examples. First up, how many grams are in 17.5 liters of helium gas at STP? So we'll put down the given, 17.5 liters of helium. We're going to try to convert that to grams. When we're at liters, the conversion we know with liters is liters to moles. So we're going to use that one. The thing that should go on bottom is the thing that was previously on top, and that is liters. So we'll put 22.4 liters of helium on the bottom, and that is equal to 1 mole of helium. Liters goes away. Now we're in moles. We're trying to get to grams, so we need to do a grams to moles conversion, or moles to grams, which uses molar mass. So we need the molar mass of helium. To find the molar mass of helium, you need to go look at a periodic table, which I'm trying to pull up right now. There it is. Oh, got too many. Need to make it go away. All right, so here's our periodic table. We go look over at helium. Helium has a molar mass of 4.003. So that's what we are going to use in our conversion. 1 mole of helium equals 4.003 grams of helium. I'll plug that into the chart to make the conversion. 1 mole was on top, so moles has to be on bottom next. 1 mole of helium equals 4.003 grams of helium. Moles of helium cancels out. We're left in grams. The last thing to do, as always, is multiply your top numbers, divide by your bottom numbers. And if you do that, you get 3.13 grams of helium. So this conversion works just like any other conversion. You're just plugging it into the chart. All right, example number 3 here is going to involve actual stoichiometry, which involves the changing of a substance. So let's jump right into it. Our question asks, how many grams of SO3, sulfur trioxide, can be produced with 8.41 liters of O2, oxygen gas, at STP? And this STP tells us that our conversion is valid. 1 mole of a gas equals 22.4 liters of that gas. All right, so let's follow our same process. Draw the chart. It's already drawn. Write down the given. 8.41 liters of O2. And we know to convert from liters, we use this bottom conversion. 1 mole equals 22.4 liters. We've got liters on top here, so liters goes on bottom next. 22.4 liters of O2 becomes 1 mole of O2. All right, so that conversion is used. We've gotten rid of liters. Now we are in moles. Now moles is awesome because you can go anywhere from moles. You could go from moles to grams, moles to molecules, or switch substances. Now, in the end here, this question is asking for grams of SO3, which is a different substance than the one we have. So what we want to do is go ahead and switch to that substance using stoichiometry, which involves the mole ratio from the balanced equation. So here's the balanced equation. Let's look at O2 and our new substance, SO3. We've got 12 moles of O2 in the chemical reaction, and we've got 8 moles of SO3. So we can make an equivalency or a conversion out of that. It says 12 moles of O2 is going to become 8 moles of SO3. And we plug that into the chart, just like always. We look at what was on top. It's moles, and both sides of our conversion are moles, so we have to look at the substance. It's moles of O2. So moles of O2 goes on the bottom next. Whatever is on top goes on bottom next. 12 moles of O2 becomes 8 moles of SO3. So moles of O2 go away. We're left in moles of SO3. But we're trying to get to grams, so we got one more step. To go from moles to grams, you have to use the molar mass. And there's a nice molar mass chart ready for you to use down here. First thing is writing down the elements that you're going to use. We're going to have sulfur and oxygen. And there is 1 sulfur atom in that because it doesn't have a subscript. There's 3 oxygen atoms. The average atomic mass, we'll go look up on your periodic table. Sulfur's is 32.066 grams. And oxygen's is 15.999 grams. Then you do some nice multiplication between those numbers to get 32.066 grams total for sulfur and 47.997 grams total for oxygen. Then you add those up, get 80.063 grams is the molar mass of SO3. And when you find the molar mass, that is a number in grams, and it equals 1 mole of the substance. So I'm going to fill that into my little conversion up here. 1 mole of SO3 equals 80.063 grams of SO3. So we plug that into the chart. Moles of SO3 was on top, so moles of SO3 goes on the bottom, and when you use molar mass, it has to be 1 mole. And then your grams goes on the top, 80.063 grams of SO3. Moles of SO3 cancels. All we're left with is grams of SO3 for the unit, which is awesome. All we have to do now is multiply all of the top numbers and then divide by all of the bottom numbers. And if you do that, you should get a nice 20.04 grams of SO3. All right, guys, hope this was helpful. If not, rewind the video and go back, try to figure out what we did. You do have a test over this on Monday, so if you have questions, please email and ask.